Hi, Tor, and everyone.
Hello.
Hello, Tor. So good morning on your side. We're waiting for Master Brown.
Hi, I'm here.
Okay, good. So I can start sharing my screen. And I need to share. This is weird. Every time when I want to share the screen, the browser is not in one of the shareable screens. Oh yeah, I see. This is it. Okay. So, okay, good morning. So let's talk about stuff. Yeah, okay. So so let's first do a quick review of the previous meeting. If we don't, we'll forget it. This is what I wrote from memory. So basically everything is simple. The attribute can originate from a call or from an event. And if it's from a call, then notification service is not of any help. If it's from an event, then notification service may be of some help. Because the events have the you can index for the occurrence whether or not the event has occurred between now and the caged time and now, and the volatile elements are specially marked. For example, if the function if a call returns the current block height, then it's volatile. That's all right. Okay, so far so good. So far so good.
Yeah, line number 3, volatile. I don't know if we talk about this. Do we use a keyword volatile or Boolean volatile?
No. At that time, we said caged equals to false. I don't know what is the best way to do that anyway. So let me try to write it down, and maybe we should do that instead.
So would that be like an internal engine implementation?
Like something like this. Yeah. Yeah. So this
because I wonder if we should also think about like a time to live instead of a Boolean flag.
Yeah, in the final way, right? So TTL equals to 0, meaning that it is like this, right?
Yes, something like that.
Yeah. Okay. That's something I'll write it as TTL for now, because we will have an overview when the test station is added into the matrix. Okay. For now, I don't really mind which one to use until everything is together. Then I can form my opinion. So this is good. So if the attribute has two values, two regions with the event and the call, the event takes precedence if the two and the event is placed before a call, right? The event is placed before a call, then the event takes precedence and the call is only used for initialization. Okay. The situation, the situation
providing that. Oh, sorry. Yeah. Karen.
Yeah, the situation is a bit complicated because the engine searches for event after the call, meaning that the engine is going to look for the remember the time of the call, the block height of the call, and then next time it will search for the event between that time and the current time, and then it will replace the caged call value with the caged event instead. Yeah, all right. All right.
Yes.
Okay, somehow. So remember, we said the event is caged the event is caged entirely, because usually one event returns multiple attributes. we have not gone so far to map the database structure. This is just some generic comment.
Yes, I was thinking that would it not be better to handle them on a per attribute basis rather than caching the whole?
Then you cannot, for example, if there's Oracle that returns the current Ethereum price, and that is being used in attribute of 100 tokens, in theory, you should only get the event once. But now, because it's a separate attribute, you have to go through everyone and cache everyone. It's just the relationship, relational database concept. Like we can probably build it to the, if we design table right, you should only fetch the attribute for the entire set of token scripts once if the event is used across.
Yeah, okay, seems reasonable.
Yeah, this is an implementation detail. Even if you don't do that, there's not much performance loss, and we can always change it later. If the event doesn't have a select, it is used to trigger the engine to call, make a call. This happens, make a Ethereum call. Yeah. If Ethereum event doesn't have a select, it uses trigger Ethereum call. This happens when the event and the call are in different contracts, for example. And this is the syntax proposed by Bone, right?
Yes, I think so.
Yeah. So to which I agreed. The final vision will be, we'll take a testation into origin and then we'll have an overview by that time. So this is so far the thinking draft, not even draft spec, but a thinking draft. Then this is what Sunil used to like to call strawman, but I think that word is abused in corporate environment. Anyway, this is what we had last time, right? Okay. Okay, so come back to this one. We are moving to the testation project, and this is about the right time because we need to integrate a testation as one of the origins. But before we do that, we work in parallel universe. That on the one side there are events and the calls, and the other there are testations, and then we will try to marry the two words. That might make thinking easier. So what you are looking at right now is the attestation, identity attestation, identifier attestation used in the send ether to identifier protocol. So let's first look at the protocol, okay? Send ether, yeah, I think this is it. Actually, yeah, this is the protocol. So last time we discussed that protocol and we improved based on it. And later I rewrote the protocol with the improvement already in there. So there's only one version now. And I make this shareable screen just big enough so you can see the entire protocol, okay? Yeah, okay. So that means I need to stop share again. Yeah. Okay, guys. So let's go through the protocol. This might look unfamiliar to you because it changed a little bit. Then we go to the testation. Paul, did you have some time to read this before coming to the meeting?
Yes. Yeah, it looks fine as far as I can see. I'm still I'm considering if there are any issues, but I can't see any issues. It seems very similar.
Correct.
Just considering like all the different possible attack vectors. But I think it's within what we want to achieve.
Yeah.
I mean, the issue is still like Bob now. He still needs to save his original S and keep that.
Yeah.
Definitely. So that's a bit annoying.
Yeah.
I mean, we're trying to do something without a lot of interaction, and without using too crazy advanced crypto. So it's we gotta got to make some sacrifices somewhere.
I think we decided for the Bob to keep some value anyway. So it's only matter of the only thing is now write it in a way that attestation and check are independent processes. Where the previous one, the attestation is obtained after the first check.
Right.
So the reason that I make it independent is because, for example, if you do secret sharing or if you try to log into a website and you want to fill in your email address as a, subscribe the the newsletter, then the website can use attestation instead of asking you to receive a verification code. And this might have happened before Alice ever sent the check. So Bob probably already have an email attestation in order to do secret sharing, which involves a tested email address, or in order to just log into a website with a tested email address.
Right.
So without diving too much into the protocol, let's just look at what is needed in the protocol. So first, there's an attestation needed. And for that attestation, guys, do remember the structure. The structure is, attestation structure is, the core part of the attestation structure is the data object, right? This is what is being attested. Like my telephone number is this number, which is data object. That's how we did that back in the 10th or 11th meeting in last November. So the core part of attestation is that object, or I probably should call it attested, but because that object is shared between attestation and Ethereum blockchain event, I don't call it attested. Otherwise, you get the idea. So that object is the core part. And enclosing the data object is the to-be-signed information, which include, for example, the public key. And to-be-signed information is where, what does it look like? Okay, let me find it, okay? So go to the community website, let's look at it. I guess it's TBS. Actually, it's the, which one? No, not this one. Public key info, I guess. That's the search keyword. No. Data object. That will be too wide. We'll get a lot of results. Okay, this one maybe. Okay, so actually, let's look at the thing. Okay, so the core part is that object of attestation, right? You guys can see this, right? And then enclosing it is the signed info. Sorry, not to be signed, but signed info. And enclosing the signed info is the attestation in whole, right?
Yeah.
Okay, so that's what we had last November. So let's look at this one. For this to work, Bob has to create a create a Ethereum key, which is already there, and it's not part of the attestation. And then he will have this corresponding subject of the attestation. Subject is here. Where's subject? Here, I think, right? Subject is a sequence of key value pair. Okay, and then you need this bit. Actually not this bit, the whole bit. I think this is the whole bit. Yeah, whole signed info section is used as certificate signing request. Is that right? And then and once this whole thing is being signed by a tester, it becomes attestation. So let's look at just this 1, 2, 3, 4. All the data needed, all the token script needed for this 1, 2, 3, 4. The check thing is not in the first part of the project, but it will come later. So let's today only look at this. Okay. So here is a draft. I can share you in the editable mode. Let me do this. Okay. Now this should be good, right? So first, we need a few modules. One is this one. This is the data object, the core of the, what is tested. Okay, and another module which is the signed info. Signed info and attestation are implied. TokenScript authors should only, oh, damn it. Should only care about the core part, which is what is the information tested data object. Okay, so two modules. There are two modules. Okay, so so by having this, attested module equals to identifier. What it means here is you have a attestation whose data object is identified. So identifier is very simple. First, it says what is the type of the identifier. You can put either email or it can be mail or tele or mobile. Let me find the code just to be specific. Oh, sorry. Hold on. Okay, so that is clear. So the first is it can be either actual email address or mobile number here. Okay, so this, sorry. So this whole thing, damn it. This whole thing is the data object to be attested, and this is the module of it. Okay, this is the module of it, and this is the instance which is used in the attestation, which basically say you have attestation to be stored on the user's wallet, whose data object is modeled after this module. And the rest of the bit, like signed info and attestation, are implied. So the word attested simply implies everything, because we standardized this, how to put signed info there and how to put the entire attestation there. So we might have other fields like in this case, who is the accepted attester or whatever. Yeah, only if it's signed by this guy it's correct. And together with this attestation, there is a secret. Attester. Together with this attestation, there's a secret. And let's give it a name. Attestation S value. Okay, actually S, let's simply call it S. Okay, so this let me think about it. Yeah, yes, okay, so this is the whole attestation file without taking care of the certificate signing request part, just the attestation part. And that's the HTML we need. And the reason the secret is using the module private key info is because it's already defined somewhere. Okay, so I will not go into the detail of private key info, how it is defined. Just imagine it's being the format for containing private keys. So this would be attestation, the definition of attestation. So far, so good? Yeah, this is what I want to share with you. So if you guys look at this and think it's passable, then we will move on to talk about what is inside private key info, which is not a really big topic. The big topic is just the attestation here. Does it make sense so far? So if someone wants to write TokenScript for such attestation to be used in this protocol, he needs to provide these stuff, which is it looks like it's less than 10 lines. Should be easy. Yeah, okay. Any questions?
It seems like this is something that there might be a wizard to help help someone generate this attestation.
So let's say somebody designed a protocol that is not sent either by an identifier but by a hotel. Let's say let's say something else to be attested. Okay, age is too complicated actually. Hotel. So let's say you write a smart contract which with 300 ether in it, and sorry, 1 ether in it. And any hotel who is able to offer your room, provided that they are a 3-star hotel in Paris, is able to send a transaction to your smart contract and redeem and take the money in exchange for a hotel voucher, which you can stay for a night with. Let's say it's the other case. The guy who designs the protocol, which says the hotel needs to provide attestation such as they are 3-star and such as stuff, will need to write something like this. He will need to write in this section what is to be attested. For example, hotel level stuff. Yeah, this would be the hotel attestation. It might be more complicated, like the location of the hotel or whether or not it's 3-star. It will be embedded in the sequence bits. And once he has done that, the other is relatively standard. You define attestation that attests to this. And then typically it doesn't have a secret. But if it does, then you define a secret here. But both these two the following defines what are stored. Yeah. So from line 5 to line 22 defines what this data look like. And this defines how many copies of this data. Like you need, these are like the instance of the data module. Like you need a identifier which is attested, and you need a private key. And these are the module of that. And actually line 9 can be omitted because in many cases, the secret is a private key. So it's implied. So if you say that you have a secret, then it's automatically using line 9 to define what is in the secret. what is the format of that secret, unless you have special format secret, which can happen if you have stringed protocol, or anyway. Does it make sense? Any questions? Should I move to the next one? Or is this very confusing?
When you populate this, like an example population, you'd actually put the data object would go inside the attested key.
This means that there is that object to be attested.
Sure.
This is the data object's schema, if you call it. Well, I call it module, yes. But the schema.
But is it packaged? It's packaged within this file or alongside this file?
What?
It's packaged inside this file or alongside it?
The actual data.
Yes.
Well, let's say, for example, Tor wrote a magic link. Remember a while ago, magic link which has a attestation in it, right? So if you click a magic link, then the engine will take the data object from the, actually it will be a attestation in it. It will take an attestation from the magic link and then store it in the user's computer.
Yes, and I understand where the data is coming from in that instance.
But outside of magic link, I don't know. Like
right. Okay.
Yeah.
Maybe so basically it's like a payload or something that's attached to this. Okay, that's fair enough. Yeah.
Well,
okay.
Maybe we have we defined a few cards on this attestation so that you can do things just like tokens. But right now I'm just looking at the declarative part of TokenScript, not looking at the executable
okay,
part.
Sure. Yeah, okay. Yeah. I was just curious how.
But if you have magic link, maybe you don't even need the executable part, which is why I use that as an example.
Yeah, because the payload's clearly defined where you get the data. Yeah. Okay.
So the executable part is going to be card, but how does the card look like? I haven't write a card for it, but I imagine it will be very similar to the token card. So for example, this one doesn't say what you can do with the attestation, right? So that is going to be in the card. This is just the attestation. If you have such attestation, you might have a few actions. For example, prolong this, renew this attestation, or use this attestation to cash out a check. That would be the action, I guess. Yeah, so this is like TokenScript with only attribute definition and the event the data module used, data objects used for events, but nothing else, no cards, anything, just to make it simple. So the working part of this file is only these lines, the 13 to 22, and this line, effectively, actually these two lines. So it's like 1, 2, 3, 4, 5, 6, 7, 8. Only 8 lines are like that means something. Basically, it defines a testable data object that has 2 elements in it. One is the type, and the other is the identifier. Make sense?
Yes.
Okay, and Bua, you're okay with this too? It's not set in stone though. It's just a very early draft.
Yes.
And you understand every part, the purpose of every part, right?
Yes, I think so.
Okay. Okay. Oh, good. So about parsing such a attestation. Let's say you receive 150 bytes of data, and you want to parse it and store it. That is done through the implementation of how to parse an attestation or how to even construct one, if the attestation is defined to be allowing user to construct, is largely done with ASN.1 library, and not to be actually coded by ourselves. So I will go to an example to explain how this process is done. I don't have an example for the very data object to be defined here, but I have an example for something similar, which is the private key info. So let me turn this off, and let's look at private key info. And share screen. Share, okay. Okay, so this is private key info. It's pretty long. Sorry, this one. This is private key info. It's pretty long, but you don't have to be concerned with it because it's just RFC. It's RFC written in XML language. Basically defines like how to declare a private key. What is the parameter of the private key? What is the curve that it is on? Whether or not it's ECDSA or blah blah blah. And you don't need to write any software to deal with this code, because it's going to be translated to this, which is the schema of the data of the blob of data called private key info, and this is going to be taken into a library, this library will be able to understand this this chunk of data, understand this schema, and then correctly interpret a coming private key or store a private key correctly. Now, imagine this being a data object, because this is a RFC. This is a private key info. This is shared between all the test stations, every one of them, as long as they involve a private secret. But imagine this, instead of being the private key info module, it is, you can see it starts with the same thing. It starts with module and it starts with sequence and stuff. Imagine this is not FIFA ticket. Yes, FIFA ticket. FIFA ticket would be a good example. Imagine this being this section, okay? From line 13 to line 28. Imagine this is being the data being attested, the data object. Then it will be translated into something like this in terms of format, where instead of version, it will see your ticket number, your ticket class, therefore fed into a library which is able to generate or interpret such a binary blob of data. Make sense? This is me explaining the process. It's not the coding work we have to do, because the translation is by another library, and the understanding of the data object, the parser, to pass the binary data object or construct one, is from another library too, which is what I'm working with Tor to evaluate, like which library to use. But there are such libraries.
Okay.
And what we do is just to evaluate the existing libraries, what's the quality of them, and then write a translator connected to library component, so that if you define the data object here to be attested, for example, then the library is able to swallow the blob of data. And the test case will be swallow the blob of data that comes with a magic link, because that's the simplest. because that's not swallowing a blob of data from a website or email or a smart contract. It's just a link which has binary data in it. And for the TokenScript author, he needs to define what is in the attestation, like a numero, owner, and the class, and the starting time of the event. If somebody wants to write a FIFA ticket for, if somebody wants to write a new ticket, like Olympic ticket, he want to write the TokenScript for Olympic ticket, he just needs to define his own data object to be attested, and then with the help of this library, he's able to construct individual tickets as magic link, and or consume them by having magic link sent to the mobile phone, and then it was taken into the cache, the data, into the storage of mobile phone. Of course, after validation, because validation is done too by the same library, which understands what this data object. It also understands how it is attested. And this case, observe that this FIFA ticket, let's say for example owner, its type is a binary string, right? Like this is an octet string, which is like binary bytes, which is another way to say bytes. And there's Ethereum type too, which means that if the same data object is used in event, then it's going to be Ethereum type, because the situation is you can get a ticket as a attestation, or when you transfer the ticket to someone else, an event will be generated, and the person who receives the ticket will no longer have attestation, but a blockchain event instead. So that's why the same data object can be encoded differently. One is in the attestation, and the other is encoded in Ethereum.
Okay.
Yeah. Okay. So that's the idea behind the design so far. We have not touched about the flow of how to write a card from A to B, and we have not dealt with it. We just look at data. So the way I typically work is work on data first before working on the software, because once the data is clear, the executable component is relatively easy to make. So this is the model, and it also makes sense to you too, right, Tor?
Yeah.
Okay, so we have about 7 minutes, and let's be in an open discussion of this thing.
For line 16, what if specifically for numeric types? 16.
This one?
What if it's a numeric, floating point number, for example? 16, that's 17.
This one?
Yes.
Owner, right?
Yes, but what if it's a number, floating point number, and the types don't match because they are across two different systems? Yeah, I imagine we will have more systems.
So we might, but to trust attestation is easier than trusting a data that comes from TSL, because once it comes from TSL, you lose the authenticity. This is the schema of the data. If someone produce a attestation that has numero, which is integer, and followed by owner, which is not integer, then this blob of data will simply not be taken in because it violated the schema.
Oh, sorry. Then I gave a bad example. Let me try again. Look at line 15.
This one, yeah.
Yes, is type integer. What if on Ethereum it doesn't fit?
That's a problem.
Or the other way around. So different systems, they have different types. So I'm thinking especially about numbers, floating points, where that's usually more problematic.
So, yeah. So one thing about this is, well, if the data is only 1 or 2, then ASN will be quite compact. It will only take 3 bytes. or maybe 2 bytes, 3 bytes, yes, 3 bytes. If the data is, on the other hand, longer than 256 bits, then it will store perfectly okay in S and X, but have a bad problem if it is used on Ethereum, right? Because
Yes.
you cannot have integer larger than that. Then actually you will have a problem halfway down, because the Ethereum integer is not signed. But anyway, if we have a Ethereum type here, I would imagine that means I don't know what will happen. First, I would imagine that if the incoming data blob violates the range of Ethereum type equal to integer, then the data blob cannot be taken in. But that's doesn't have to be that. That's also messy.
You could turn it into a bytes 32 and hash it if the type was non-standard. So you could have a bytes 32 hash of whatever the identifier is.
Yeah, but then what if the actual value is referred to somewhere down the way?
Okay.
Yeah.
String then.
It might not matter, but I'm just thinking whether this could be a fundamental problem, because once it's set this way and it comes up, we can't fix it.
Yes, you're right. Does it worth effort? I mean, on one hand, if the user defines a blob of data for like an ABI structure, and then define another for attestation, it will be doing the same work 2 times. But if we uniformly say the data is, if we uniformly say the data is always ABI, then it's going to be pretty long. We have a lot of integer, and then every time we attest it, it's going to be 32 bytes, and guess it's expensive. If we say, and we cannot overrule Ethereum, you see, the way the roads are blocked. Number 1 road, which is to define 2 things. One is called name registered as a event, and the other is define name registered as a testable object. Then it's confusing because when you make a reference, you don't know which one you're referring to, or whether or not they all have the same fields. If you do it the other way around, like if you only have one, that is ASN.1, then how do you encode it in Ethereum? If you only have Ethereum, then you have to encode everything in Ethereum, which is really long and not very flexible either, and not upgradable either, because attestation format like ASN.1 is intended to be updated without invalidating the previous ones, but Ethereum types are not.
Okay.
Yeah, so it's really ideally Ethereum should be designed first to separate attestations from the runnable code in the smart contract, like Corda did. And second, so separate data from the data schema from the application. And second, make the data schema extendable, because smart contract is going to outlive some of the data. Data is going to outlive some of the smart contracts, and you have to extend it sometime in the next round. For example, you might add a new field called country, if the FIFA ticket is by country, or like expiry. If you might want to add a new date called expiry, then you don't want to invalidate all the previous events. With attestation, you can design a data format that is extendable, but if you make it into program, like in the Ethereum way, it's lazy design where data structure is actual program, then it's difficult to extend it without invalidating the previous data or making the program who is able to access the previous data access the new ones. So this is an inherent design problem of code is everything thinking in Ethereum, but I cannot fix that. And there will be some issues down the way, you're right. Yeah. Good question. I don't have an answer for that. Yeah, it's going to be really messy if you want to make ABI extendable. It's not produced in such a way that is intended to be extended. Yeah. Okay. Anything? I think it's the end of the meeting anyway. Todd, do you have any question to me?
Not exactly. I mean, I took a look, as I mentioned, on those different possible solutions for passing ASN1, and yeah, I'll have a I'll have a closer look at this OSS thing and see exactly how it costs and if I can get that to work, because I mean, it's a bit unorthodox to basically just receive an ASN1 module and an encoded element and then pass it straight into a Java program or iOS program.
Yeah, it's not it's not usual where a library has to deal with dynamic that is defined by the user kind of schema, right? Mm-hmm. Mm-hmm. So we need to see if the library handles that situation well, right?
So we need to, what do you say? We need to
check if the library handles that situation well.
Yeah, exactly. Yeah. So I'm gonna have a look at that and see if I can find it, and also try to. I mean, this is not an open source library, unfortunately. It's like a commercial thing, but I was not able to find anything that actually did it. I mean, Bounty Castle, as a row, Bounty Castle does a little bit, but it's still like either you're gonna have a hard time writing a program that basically like tries to use Bounty Castle to the code and then like checks if, okay, is it this type, is it that type, is it and if it's that type, then what do I do? I mean, basically Bounty Castle can take some sort of encoding without like a without an explicit module specification.
Mm-hmm.
And you can do some checks on what this encoding is, and then you can use it that way. But I think that's going to be really cumbersome if the user is free to define whatever ASN1 module they want, because then basically the code would like decode one element of the encoding and then try to figure out what to what is that, what to do with that. And I don't think that's a viable option. I think the closest, as mentioned, is this OSS, where it seems you can, so there's a way of encoding ASN1 in either JSON or XML. And I think if we first have it in that, as I mentioned, if we use this library to basically pass a standard DER encoding of ASN1 into like a JSON file, basically, or JSON object, then I think it's much easier to just handle, like, use standard JSON tools in our code to do what we want. I guess the question is if we still want to, like, the question is then like how to verify against the ASN1 module specification, which I guess is still like a bit of a I think that would probably need to be done, and that's still a bit vague to me how we're gonna, like, even with this sort of library, how we're gonna be able to handle this. Yeah. Yeah, I don't know what if there's anything useful to say or whatever. It's a bit of a hard issue to decode this and then get a JSON file, but we don't know the format of the format of the JSON file is again specified in this ASN1. Yeah. If anybody has any thoughts, because it's very it's unclear to me exactly how to proceed with this. I take that as no comments. Okay. Anybody still there?
Yes.
Okay. Okay. At least that's good. I guess the main thing we could hope for is converting the module into, oh, I see most people left. I think the best thing we could probably hope for is converting the ASN module into like what's it called, XSD, is that the sheet specification of XML or something like that, and then have the data itself encoded as an XML file, and then we can use standard tools to use and validate. I think that might be the best way to go, or rather the only way, unless we want to write some pretty advanced stuff from scratch. You have any opinion about that, Boone?
Are you saying that is going to be hard to get an existing library to be able to parse it?
Yeah, because
parse both the format as well as interpret the block.
Yeah, because basically most libraries they pass the module specification into like a Java object file, and then you can decode an ASN1 encoding into like a specific Java object or something like that. But that doesn't really work on runtime when the module ASN1 module specification is part of the input.
Yeah, okay. So sorry, I was offline for a long time. So I guess, Tor, you're explaining that the library you're looking at can take a module as input, but normally people don't do this, because normally when people want to make, for example, something like a testation, they would write software that only work with one type of testation, instead of like us, where we want to achieve tokenization by making everything easier for someone who wants to define the testation.
Yeah.
Without writing a program that only handles that attestation. Also without having to force the user to entrust the program, believing that it only handles the attestation, not having any ill intention. So we do this by having the attestation format declarable. And that's not the typical use case before blockchain, right?
Yeah.
Yeah, okay. So was that one question from Boone or Brown?
Yeah, I mean, Boone asked about like the standard libraries and what they usually do, and
there are loads of libraries, but we're looking for the ones that can dynamically take the module in.
And as I mentioned, like the only thing I could find that would like probably do it is like this OSS thing. And the strategy I mentioned for doing this is probably like this, converting basically an ASN1 encoding into like a JSON or an XML file. Like in particular, if it's an XML, then I hope there's a tool to convert the ASN1 encoding into an XSD or XSLT. I forgot the names of like the schema specification. So then we have an XML file and a schema specification for that XML file, and then we can use standard tools to parse it, basically.
Yeah,
and then
basically take a binary blob of data and turn it into something comprehensible.
Yeah, I mean, like an XML or JSON file is of course comprehensible, but so the question is if we want to actually verify it against some sort of schema. I mean, like one thing is we get this encoding, and then what pops out of this library is an XML file of the content of this encoding. And my question is that good enough? Because we don't know if this I'm not sure if we assure that encoding matches the schema. I mean, okay, I'll need to look further into, like, see if I can get a trial of this library and look further into into exactly what it does.
Yeah,
like, I mean,
yeah. So your question is, let's say this guy who defined the FIFA ticket says that there are 3 classes, 0, 2, and 1. However, although he defined clearly there are 0, 2, 1, 3 classes in his module, the library might still take in a attestation that says the value is 4.
yeah.
Yeah. Okay, that's something to be checked.
The first part is basically if it can be passed into something comprehensible based on some schema. Yeah. I'm gonna have a look, and then hopefully I'll know a bit more of what the remaining issues will be.
Mm-hmm. Yeah. Okay. Yeah. Thank you very much. So I'm here to answer any questions. Other than that, it's we already abused our time. Yeah, anyone can get off anytime.
I just want to say I've been so we finally managed to get all those libraries and fixes into like the pesto implementation here, and I made a branch and started working on the server side. I'm not that far. I made a branch. I cut out all the pieces and things that were superfluous, and started adding some placeholder logic for handling our specific cases. But there's still like a lot of work. But I just want to say, like, we got like the fixes in that I really wanted to get in before I made a branch, and I made a new branch and started coding it according to what we want to achieve.
Yeah, thank you very much, Tor. It's like this. You can just bill us for the part of work that you think is not part of the project. In the meanwhile, on our side, we had a meeting that our internal core developers, which are Bourne and Brown, are too precious to be allocated into secret sharing. So we hired a company. Actually, we found a company who says that they have a cryptography and security engineering background to provide the necessary code to work with your side. And that company was in negotiation with us. Previously, want them to take this thing, but Victor and I grew cautious because although they mentioned they have a lot of cryptographic engineering background, we won't see that for sure. So we decided we produced a test task to them, which is simply to take in certificate signing request, CSR, and produce a testation. Except that this time, the CSR is by our ASN.1 module, and the testation is by our ASN.1 module, not the standard at OpenSSL. So if he's just if he's just standard one, he just use OpenSSL and give it to us, and project done, right? So we want them to see if there's a variation, then will they be able to handle it? And if they give us something similar to OpenSSL, but with the ASN.1 module we provided, then we know that they are able to do more complicated stuff. You think that's a fair test? Yeah. So we're waiting for them to deliver that test, and we will see. Then I will try to connect you to them if they are successful in the test, and then we do an outline of component list and how to deliver those.
All right, great.
Yeah. So yeah, that's all good.
Yeah.
Yeah. Okay. Okay. Yeah. So that's 11. That's 8 o'clock already, guys. Have a nice dinner, and I don't know if the open or virtual drinking will be happening, but if it is, it's going to be 1.5 hours later, right?
Yes.
Okay. Okay. See you guys then.
Thanks. Bye.
Cheers. Bye.